Hey everyone, Mike here from Arnold Tutoring, and in this video we're going to take a look at the basic definition of what a limit is. We're going to get really into limits throughout this course, so sometimes it's easy to have a nice sort of general definition and a visual so that we can sort of follow along to what these things are actually trying to say. So we're going to get really used to seeing this notation here on the left. In blue, it says, the way we say it is the limit as x approaches a. So as the x value of our function approaches some particular value of f of x, so the limit as x approaches a of f of x equals L. Now this L is the answer to the limit. And all we're saying here is that as x gets really close to some value a, the y value gets really close to some value L. I'll give you an example. In this blue graph here, we would say the limit as x approaches 2 of f of x is just our function, this limit equals 5. And the reason we can say that is that as you follow the graph, I'll do that in orange, as you follow the function and we get closer and closer to x being 2, you can see that the y value is getting closer and closer to being 5. And that happens not only from the left, but from the right. So I can say, okay, I'm going to come at 2 from the right, on the x-axis. What's happening on the y-axis? We're getting closer and closer to 5. So that's how we know that's the answer to the limit. I'll repeat it one more time. As x gets really close or approaches a certain value, what is y approaching? That's what a limit is asking. Let's take a look at the green function down here. I mentioned that the reason this limit on the first one is 5 is because it approaches 5 from both sides. In other words, as we approach 2 on the x-axis from both sides, the y value is going to 5. Let's take a look at the one down here. What's the limit as x approaches 2? Well, we can see that there's something different happening here from the left and from the right. So I'm going to start by doing a limit from the right. So as x approaches 2 from the right, we put a little plus up there of f of x. What's happening? Well, as x approaches 2 from the right, that's over here, and we're getting closer and closer to 2. What's happening? Y is closer and closer to 5, right? It's a straight line. It's approaching this term right here, so we're getting closer and closer to 5. So I would say this limit is equal to 5. What about the limit as x approaches 2 from the left? Again, with a visual. From the left of 2, that means it's coming from this side towards it. Well, I didn't measure this on the axis, but we'll call this 1. Well, you can see as we approach 2 from the left side on the x-axis, the y value is getting closer and closer to 1. What happens here when these are different? That means that the limit in general as x approaches 2 with no direction on it of f of x does not exist. Let's look at that one more time. Because it's a different limit coming from the left than it is from the right at 2, that means the limit at 2 does not exist. These limits still do exist because we've specified a direction that we're approaching, but when you don't specify a direction, like in this one up here, it only exists, the limit, if it's the same from both sides. So hopefully that's a good indication of what a limit really is. We'll get into more algebraic examples and things later, but if you can remember that all it's saying is what's happening to y as x gets very close to a value, that's what we can just keep in mind for a limit, and it's going to really serve us well for the rest of the course. You can always send us more questions through info@arnoldtutoring.com, and I'm excited to do more of these 1505 videos. Thanks.